So now you've seen how we read data in. But when we read it in, we're reading it as a whole line at a time. And it's hard to represent many pieces of data on a line and cohesively know what's going on. See, a line of data isn't an object. In Java, we like to think in objects. We have a person object, a first name, a last name, an age, a date of birth, all that sort of stuff. And we can store that stuff where there's clearly a attribute for it, and getters and setters to deal with that, and it's nicely organized. When I take that data and put it into a file, there's some formatting that goes with it. Now, there's pretty people formatting, which is maybe last name, comma, first name, and then the next line is date of birth, and the next line is, but that becomes difficult. We have to have some clear rules on that. What's easy for people to read is very inefficient for a computer to read. So we have to find ways of storing an object as a line or some other mechanism in a file, and then be able to read that back in predictably every single time and be able to know exactly that we can get that data back in. So, for example, let's say we want to represent a multiplication table in a file. So we could have 1 times 1 is equal to 1, 1 times 2 is equal to 2, 1 times 3 is equal to 3, 2 times 2 is equal to 4, 2 times 3 is equal to 6, so on and so forth. I know you can do the math real time, but let's just say we want to put in a file for some reason. So this multiplication table has a format to it. I have one number, which is the left hand, another number, which is the right hand of the multiplication, and then the third number, which is the total. And we've basically saying number, space, number, space, number. That's our formats out here. Very, very simple. So when I read this file, I have to read it in one line at a time and then break it up into 3 data points. So the design of the file is me as a human picking a format arbitrarily. I could be an answer space left space right, or answer space right space left, or left space answer space right, or whatever, but it's up to me. As long as I read it and write it consistently, it somewhat works. But I define it. I have to be the designer. I have to be the human who's smart and makes that happen, and then the computer program goes from there. So reading this file then, I read it in one line at a time, and what I'm recommending for you to do is have a separate method inside of there to actually deal with that line. You see I have a method here called parse line. And so the parse line statement takes that string, which is all the characters on that line, excluding the new line. The new line's taken off. And I'm looking through the characters for, in this case, where do the spaces lie. So one of the ways we can do that here is I can use the string feature, index of. Now we're talking about string parsing now, so we're not really talking about I/O at all, but we're talking about a key utility I need to be able to realize my files and streams and reading data and stuff. So the index of tells me what's the numerical index of the next occurrence of this character that I'm asking for, the space character. And then I can say index of again, which is the next occurrence of the space character after some number I've provided. So in the first case, I start at the beginning of the string, and I find the first space character. And the second one, I go to the character after the one that I just found and ask for the next space character. The assumption is that there's 2 of them out there. If there isn't, this actually returns a -1, and then I can deal with that from there. But then the first number out there is if we go to that string again, ask for a substring, starting at the beginning of the string, going to that first space character, we can turn that into an integer, and that's our first number. And then if we go from the substring where the character passed the first one to the second one, we skip that space character, then that's the second integer. And the third is everything that comes after the next space that comes out of there. So at that point we have an integer, an integer, an integer, and we can go and print out the results of that. And I wouldn't necessarily have to do it here. I could return an object, I could return 3, but that's what I'm doing in this case. So you can see my index of is used to find a specific character in the line. And it's just a tool that I'm throwing some logic out there. Not terrible logic, but it's very precise. I mean, when I wrote this the first time, I remembered, okay, was this +1 or is this +1? Or there's a little tweaking going on, but I solved it pretty quickly and I got it working. Now, the index of works really well and has many good uses and is a very good tool to be able to know about and build upon. But when I have this thing called tokens, multiple data objects separated by a common character, in this case the space character, I can do something even better. I can take the logic and I can use this fancier tool to help me get this solved. So what we're going to do instead is we're going to deal with the string tokenizer. The string tokenizer out there allows me to say, okay, this line is separated by a bunch of spaces. There's numbers separated by a bunch of spaces. And so the string tokenizer says, take this line and create some number of tokens based off of the spaces that are out there. Now, it should so happen that everyone's 3. If it's not, then it could be problems. We'll talk about that later on. We're dealing with the basics of string tokenizer. So what it does is goes through and takes that line and it says, oh, there's a first number, a second number, and a third number out there. So I can take the first token, it have to be the first number, so you can see that right here. I split it up in tokens. The first one's the first number, the second one's the second number, the third one is the total. And so the same code I just did before, without the math, without the substrings, without that sort of stuff, I can still get my first 3 numbers out of that line. Pass in a line, get my first 3 numbers, print them out. Now, what it's doing inside is essentially the logic we saw before. The difference here is I can do different tokens. I can do multiple tokens. If I do comma, asterisk, star, asterisk, colon, it'll use any 3 of those as a tokenizer, as a token inside of there. It'll split up by any one of those rules. It will not do multiple character tokens. That's one limitation it has inside of there. So the way this works again is in the constructor I give the string that I want to break up and the delimiter, which is also a string, and as I said, it's a single character or some combination of characters that each individually act as the tokenizer. So again, comma, exclamation point, and would be either the comma or the exclamation point or the and character inside of there. And so once I have the constructor completed, it can tell me how many tokens I have. It'll let me get the next token. It'll let me ask, are there more tokens out there? Loop through them. And so my logic here depends on how I design the file. So how many do I expect? Is it dynamic across the line? Is it based off the data that's inside of there? That's why it allows me to loop through them one at a time. That's why it doesn't just turn it into an array or turn it into an object right away, because each design is going to vary in some ways. Not every single file has to be exactly a table. It could be variable inside of there. So as an example, when I string tokenizer line, the line here is 1 space 3 space 3. This constructor breaks it up into 1, gets rid of the space, the delimiter. 3 gets rid of the space, the delimiter, and 3. And then the line actually didn't have the new line at the end, but we can ignore that for now. And so it turns it into 3 tokens, and it turns into a list of a linked list, if you will, of the 3 tokens, where I start with the first token, get the next token, get the next token, and then any other asks would return null. There's no more tokens after that. So you can see the line of these 3 gets broken into 3 objects, which each of these are strings to start with, and then I can take those strings and turn them into numbers at that point. So one thing we want to be aware of is the delimiter must be a unique special character that cannot exist in the data. So if I was doing cities, and these are all cities I've lived in at different points in time, and it's old because Aurora's over 200,000 now, and April's like 150 or something like that. But anyway, you could see Aurora, city name, space, Illinois, space, the population. Chicago, space, Illinois, space, population. Well, the issue there is Michigan space city. Well, Michigan City is all the city name. Cedar Rapids, Terre Haute. All cities I lived in, they all have a space as part of the city name and need to have a space as part of the city name. So I can't use space as the delimiter in this data. So is a comma allowed in a city name? If not, use that as a delimiter. Or a tab, or a colon, or the letter Q. Whatever makes sense as is not valid inside of the data can be used as a delimiter. And that's what we want to see, find, and use when you do the design. It's not about the code, it's about designing the file type. So again, my favorite comma separated. CSV is comma separated. What's the V stand for? But yeah, that's what you'll see in many times. So from here, go out and look at the demo. You're going to see a little bit of stuff being played with just inside of this file, just inside the delimiter. You're going to have to come up with your own strategy. You're going to have to try and delimit it. You're going to have to come up with that. It had something that has to a little trial and error. You have to play with it a little bit, but it works pretty easily overall once you do get going. So do that, and then we'll come back into what the assignment's asking for us to do with this data and with the files.